Grade 8, let's look at this revision. Bucket with this revision number 2. Okay, here we look, and the first question looks at what we call patterns. Patterns. And we have both numeric and geometric. Remember, numeric looks at values, and geometric looks at diagrams. It looks at diagrams. How do we what we expect is to know that both of them, they can be expanded or they can be extended. They can be extended. Then when we look at this, what we expect you to know, what we expect you to remember is that you should know which one is dependent and which one is independent. You understand? Independent is usually the input, and the output, it's dependent, because definitely for you to get results, they have to depend on a given value. All right, let's look at this table that we have here. This is a sequence. Okay, it only breaks way. Yeah, it's fine. Complete the missing values in the table. Now, how do you complete the missing values in the table? First and foremost, let's look at the scenario. Just records the number of cars and car wheels he sees in his street. He says one car has 4 wheels. Then 2 cars, they have 8. 3 cars, they have 4. So in that manner, what you ask yourself, 1, it has 4. 2, it has 8. Then 3, it has 12. What's happening here? When you try to see whether there is a common difference, let's try and we see by subtracting or adding. What number do we add here to get? You add 4. Okay, you add 4. Oh, there's a common difference, which is 4. Okay, then ask yourself, what was the number before? What was the number before? Here, I'm trying to create what we call the general rule. Anyway, when you look at the table, it does not need the general rule at the moment because the values that we need, there are only two missing values. So if it's 1, 4, 2, that means if I need the value here, it will be 4 times 4, which is what? 16. And here to become 6 times 4 becomes what? 24. I'm here looking at it. The 4 or the position is multiplied by 4. 1 times 4, 4. 2 times 4, 8. 3 times 4, 12. That means if you want the next one, it's going to be 4 times 4 times 4. Okay, complete the missing value, correct, missing values in the table. So we're done with that. These were the ones. Okay, so we go to the next question. The next question is asking us, which values represent the input? Which values? So someone here would say inputs. What are the inputs? You would have said number of cars. It's fine. Someone else would say value of X. It's fine. Another person could have written also the values that the way you see them: 1, 2, 3, 4, and 6. These are input values. All right. Which values represent the output values? Definitely, you would have said number of wheels. Or someone would have said value of what? Y. Or you would have written 4, 8, 12. You understand? We are looking for which values represent the output. Can you tell? Okay. Then we go ahead and ask us, what are the 2 variables that are represented in the table? So here, what are the 2 variables? You would say, still we are looking at the same story. We are looking at number of cars, or you can say number of wheels. These are variables. Or you can still say values of x and values of y. These are the variables. What do we call them variables? Because they keep changing. Okay, which variable represents the independent variable? Provide an answer. We said the number of cars represents the independent variable. Why? Because for you to get the number of wheels, you have to have the number of cars. Then, which variable represents the dependent? So, the number of wheels, because this is determined. It's determined by the number of what? Determined by the number of cars. It's determined by the number of cars. Okay. 1.1.7. Write a verbal statement. Look at that. Verbal. In other words, we are supposed to write it in words. We are supposed to write it in words. A verbal statement that relates the number of cars to the number of wheels. In other words, what do you see? So you can say here, the number of wheels increase by 4 as the number of cars increase by what? By 1. All right. Someone else would have said it's direct, whereby as the number of cars increase, the number of wheels also increase. Write a number sentence. Now here we need a formula. Write a number sentence that relates the number of cars to the number of wheels in general. So in other words, we are looking for what we say, what we call the general term. The general term. All right, there we go. The number statement, we are looking for the formula. They're asking us write down the number statement that relates the number of wheels in general. Now, you can use this, you see. If it's 1, it has 4 wheels. Then ask yourself, 1, it has 4 wheels. Okay, let's do this. We are creating a general formula. Remember, we are looking for how do we get the next number. How do we get the next number? I'm here looking at this. We said it keeps on adding what? By 4. Keep adding by 4. Keep adding by 4. All right? You see that? They kept adding on by 4. So this is a common difference, which is 4. So if you are to use our formula that you already know, it would have been our Tn equals to dA plus B. So we look for D, whereby they tell us the second term minus, that's a difference that we've already seen. So there we see it as 8 minus 4. So our D is 4. Then the B will become T1 minus the difference. So our T1 is 4, and the difference is 4. So our B becomes 0. So we come back and we substitute into the formula, whereby our D is 4 n plus a 0. So at the end of the day, the formula will become, now, this represents the y, and this represents the x. So it becomes 4x, where y is the number of wheels, and x is the number of cars. All right, 1.1.9. Oculus states that for her to get the output, she adds -3 to 4 times the input number. Help her find the missing values. Here we go. Let's look at that. First and foremost, get out the formula from the words that we see here. They are telling us it's -3 added onto 4. Let's say input, let's call it n. So in other words, this is the same as 4n minus 3. All right. So if you're to look for the value of a, what are we? This is a formula from here. This statement here, this is what I'm highlighting. You see this? She adds. So what are we going to do? We shall add also. What I want you to understand is that you have to analyze what you're going to do. So the value of a here, we shall say a. So now the number input value is, so it's 2. That means our n here is going to become 2. So our a will equal to 4 times the input 2 minus 3, which is the same as 8 minus 3. And the answer becomes what? 5. What about B? Now B, okay, let's first do the ones that are here. So A, it's done. We have also to look for C. So C, what would it be? It would be 4 times, what's the number up to C? It's 9. So C times 9 minus 3, which gives us 36 minus 3. And the answer becomes 33. Now we look at B. B, we are working backwards. What do we mean by that? We mean we already have the output. Let's call it Y. All right? We already have the output. We are not looking for, we already have the output. So simply meaning it's going to be 13 equals to 4n. We are looking for the position. We are looking for B. Right? Actually, let me put here 4B, because our n in this scenario is what? B, not 8. B minus. So here it's simply meaning there's a number they multiply with 4, they subtract 3, they get 13. What number could it be? So simple. In your brain, you know very well, 4 times 4 is 16. 16 minus 3, you get 13. Or someone else would have done this. This negative jumps over. Once it crosses the equal sign, it becomes a plus. So meaning 13 plus 3 equals to 4B. Then this is what? 4B, they are giving you 16. So it becomes 16 equals to 4B. How big is only one B? So we divide through by 4. So my B is 4. So in other words, here the value of B is going to be 13, which is that, plus the 3. We divide everything by 4. The answer becomes 4. All right. Let's look at D. D, we are going to do the same. what is the output? Because here D, we already have the output. So meaning it's 45 plus 3. Why are we adding 3? We are getting it from this same scenario here. We are looking for the unknown. We're looking for the unknown. You understand? Actually, I can explain it again and you see. When you take the formula that we have, which says 4n minus 3 should give you a certain answer there. We already have the answer, which is what? 45. We come here, ask ourselves, what number was this? So the 3 has to jump over to join this. That's called collecting like terms. So it's 45 plus 3 equals. Now, if the 3 moves, it becomes a plus. If it moves to the other side, which is the left-hand side, becomes a plus, leaving 4n alone. So when you add these two, what do we end up having? We have 48, giving us n, 4n. But we are, sorry, now our n, remember it's d now, by the way. It's no longer n, it's d, because we filled it. So we shall divide through by 4. We divide through by 4. So our d will become 12. So d here becomes 12. 48. So the value of d equals to, all right. A is easy to get, B is easy, sorry, A and C were easy to get, but B, it needs your concentration. Anyway, you give it your try. Let's continue to the second question. Activity number 2. Here we come. It talks of geometric patterns. Now, geometric, what we do, these are the geometrics. Now, if they ask you for the next step, you study and find out. Now, when shape number 1, it has how many squares? It has 1, 2, 3, 4, and it has 5. So step number 1, it has 5. Then number 2, it has 1, 2, 3, 4, 5, 6, 7, 8, 9. Wonderful. This has 9. Then when it comes to step number 3, what does it have? It has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7. It has 13, not. So here we have 13. So when you look at it critically, what happens? When you study this, they just added a 4 here. Also, they added a 4 to get that. That means the next step also, we shall get the 13. We add a 4, which has to give 17. Another thing that you have to take, in step number 1, there's a center box. By this center box, they added one box on each side. Then step number 2, there's a center box also here. But they added 2. Look at that. They added 2. Step number, there's a center box. But they added 3 to continue with it. That means step number 4, they will add 4 boxes on each and plus 1. So when you look at it, something comes in your head and ask yourself, what can I do here? What do I see? Well, how is the pattern going on? Then, lucky enough, they're already giving us a table. They are saying use the table use the information provided in the pattern to complete the table below. Meaning the missing values are A and B. Okay, how did they get their answer? So you're saying we are adding 4 when you check that. Also here we are adding 4. That means we had to have, but then take note, this is 5 and this is 6. That means a 4 is missing. So for you to get the 4th, you add 4, you get what? 17. So the 4th is 17. So 17 plus 4, you get 21. 21 plus 4, you get 25. But another way of getting it nicely, it's that ask yourself what's happening here. When it's 1, we have 5. When it's 2, we have 9. That's when we come back and we use the rule. Which rule are they using? So we shall say the rule Tn equals to D n plus B. Always remember this. Ask yourself, how do I get my D? D is T2 minus D1. Or a simpler way, if you're creating this function here, You knowing this, it's fine. Ask yourself, what is the difference? How are these numbers? Are they reducing or are they increasing? They're increasing by 4. That means our D is 4. The moment you put the D, they put the N here. Ask yourself, what was the number before this to become 5? Which number they add onto 4 to get? Definitely they added 1. So this is our formula here. So if you're to look for the value of A, all we shall say 4 times 5 plus 1. And indeed you get the answer as what? 21. Also, when it comes to the value of B, we are saying 4 times what? 6 plus 1, which is 24. 24 plus 1, you get 25. I repeat, we are getting what we call the general rule, or we're looking at what we call, we are using our general formula there that we've just created. So this simply means the same as multiplication. So here the answer becomes, for you to confirm, you can use your calculator. Just do this. 4, open brackets, 6, close brackets, plus 1. The answer becomes 25. Okay, we continue. 2.2. Someone called Karabo found out that to determine the total cost of buying books and pens in a certain shop, one had to use the following formula. This is the total cost for you to know how much you're going to spend on books and pens. Guess what happens? Where B represents the number of books and P represents the number of what? Pens. So they're asking you, determine the total cost of buying 6 books and 4 pens. Do you know what you're going to do? You're going to call on your formula. I will call it my TC, which is total cost, equals to 15. Now, 15, what is B? The number of books. How many are there? There are 6. Plus 2 rand 50 cents times P. P is the number of pens, which is what? 4. At this moment, don't forget, just put it in your calculator, find out the answer, but I believe this is 90. Then this other side you have 10 rands. You can come and put it in a calculator, which is 15 times 6 plus 2,50 times 4. And you get your 100. So if you buy in this shop, if you buy 6 books and 4 pens, you're going to spend 100. All right? That is it. Now, there's another question. Okay, imagine someone, instead of 6, the person bought 8, and instead of the pens, he bought 10. How much would it be? This is 2, ne? Let's use this as an example. We are substituting. It has changed. Someone has bought 8 books, and they have bought 10 pens. How much are they going to spend? So first and foremost, it's going to be 15 times 8 plus 2 rand 50 cents times 10. So this one here became 120 plus 25 rands. And you end up having your answer as 145. This is what it states. Okay, let's continue. 2.2.1. Now here we go. Someone, they are saying, determine how many pens one can, determine how many pens one can buy, or one bought, there's nothing. Determine how many pens one bought if they bought 5 books and they paid 95 rands. So now we already have the total cost. But remember, The formula says if you have a total cost, you have 15 B plus 2.5 P. We have the total cost as 95 rands. And they bought books, how many of them? They bought 5 of them. Plus 2.5 P. Why does the P remain here? Because we are determining the number of pens. We don't know how many pens they bought. So what we do, we continue with the formula here. You end up having 75. 15 times 5, you get 75. Plus the 2.50 P. Don't forget that. Then the 75 has to cross over. So it becomes a minus. So it's 95 minus 75. When it crosses over, it leaves on one side 2.5 P. You understand? Then when you subtract this, you end up having 20. So let me do it this side here. So on one side we have 20, and on the other side we have 2.5 P. So because we're looking for this P, we divide through by 2.5. Divide through by 2.5. Go with that, go with that. So my P now becomes 20 divided by 2.5, you end up having 8. So meaning they bought 8 what? Pens. That was the question here. All right, let's look at the next question and we look, see. This one has come back to our numbers and integers. The integers, when we look at integers, we are looking at integers, we look at integers, we are looking at negative and positive values. Negative and positive. We have some rules that we have to follow. We have some rules that we follow when it comes to integers. Rule number 1. When you multiply integers, there are some effects that you get. When you multiply integers, there are some effects that you get. When you multiply integers, there are some effects that you get. So, what do I mean when you look at integers? Which rules are they? Take note or remember that if you have a negative number, multiply with a negative number, you will always get a positive number. And if you have a negative number multiplied by a positive, you always have a negative. This applies also with division. A negative number divided by a negative number, you get a positive. And if you happen to divide a negative and a positive, you get a negative. What about the adding? Now the adding will matter, or it will change according to you. The adding will change. How will it change a little bit? So if you add a minus and a minus, it will depend. A minus and a minus, you will get a minus. Ne? Then a minus plus a plus. This one you either get a plus or a negative. It will depend. If the negative number is bigger than the plus, that means you're getting a negative. If the negative number is smaller than the plus, that means you get a positive. That's a rule that we need to know. These are some of the rules. Anyway, let's look at it. These are rules that we have to compare and see. Now, answer the following number statements, and you state whether they are true or false. Now, what do we do here? They're telling us 6 plus, open brackets, 2 plus 3. Is it the same as 3 plus 2 plus 6? This is obvious. Why? It's a 6 plus 5. Is it the same as 5 plus 6? Yes. Then the answer here becomes what? True. If you are not sure, what you do, calculate one at a time. We say 6 plus, open brackets, 2 plus 3, close brackets. What answer do you get? 11. Oh, wonderful. Then turn to this other one here. And you say, open brackets, 3 plus 2, close brackets, plus 6 equals to 11. Yes, they are equal. Let's come to this other question here. 4 times 10, what do you get? 40. Plus 5 times 10, you get 50. At the end, you have what? 90. Is it the same as 10? What do you have in the brackets? 9. It's equals to 90. Also, yeah, this is true. 3.3, let's look at that. It says 9 minus 4 plus 5 equals to 5 minus open bracket. So let's test and we see. This is when we subtract this, we remain with a 5 plus a 5, which is a 10. Is it equal to 5 minus 13? Here, the answer here, you get a negative 8. So this is not true. So what do you write? You write false. We are testing to find out whether this is true or these statements are true. 10 is not equivalent to negative 8. That's finished. Then let's look at this one here. 3.4. What does it want us to do? We are confirming. This is 15 plus 7, which gives us what? 22, ne? Equals. Now, when you multiply these two, this is 21 straight away, plus 5, which gives you what? 26. Are they the same? No. So what do you write? You write false. Please take your time and don't miss such questions. You test them to find out. You test. This is called the left hand side. Is it equal to the right hand side? If they're not equal, then it's false. If they are equal, then it's true. Okay. Look at the second question there that says, write the following numbers as products of their prime factors. Prime factors. Prime factors we usually start with a 2. What's a prime number apart from 1? A prime number is a number that only has 2 factors, 1 and itself. So we have 2, we have 3, we have 5, we have 7. These are the kind of prime numbers. But when we're looking, or when we are doing the prime factor scenario, we always start with a 2. So we shall come here and say it's a 34 that's given to us. Let's split it. Divide through by 2. 34 divided by 2, you end up having what? 17. Any other number that, because our main aim is to end up having 1. 1 should be the last answer here. So here, 34 as a prime factor, it becomes 2 times what? 17. Indeed, these are both prime numbers. Let's look at 48. What are prime numbers? What factors? And they are prime that affects 48. We have 2. 48 divided by 2, you end up having 24. Still by 2, we have by 2, you remain with the 2. By 2 again, we have 6. By 2, we have a 3. So, in so doing, because this is where it ends, this one. So, how many times do you see 3? We have, 2. We have 1, 2, 3, 4. So, we shall say 2 to the power 4. Times, how many times do you see 3? Once. So 3. So this one's the same as what? 48. Writing 48 as a product of its prime factors. As a product of its prime factors. Let's look at the second question. Next question. 56. Still, we shall start with a 2. Find out what answer we have come here. 2. 56 divided by 2, you end up having 26. 28, sorry. It's 56 divided by 2, you have 28. By 2 still, we have, this is 14. By 2, you end up having a 7. 7, 7. You see, these are all prime numbers. Anyway, what's our main aim? How many times does 2 appear? We have 1, 2, 3. That means it's 2 to the power 3 times 7. It appears only once. So this is 56 as a product of its prime factors. Then we look at 30, which will bring us to. So 30 as a product of its prime factor, what shall we do? We shall say 30 as a product of its prime factor, we shall say 30 still by 2. We start with the lowest always, eh? So we get 15. This can be divided by 3. You get a 5. 3, remember, is a prime number, eh? Then 5 can also divide here. You have what? 1. So this ends up being 2 times 3 times what? 5. Someone might ask us, how come this has no power? Because they appear once. They are all appearing once. They have powers, but it's a 1 yeah, it's a 1 to the power 1. So these ones will also give you 30. Remember, we are write the values as what? As products of their prime factors. And prime factors we usually have 2, 3, 5, 7. From 7 we have 11. We have 13 there. Numbers that can only be divided by 1 and themselves, and you don't get a remainder. These are prime factors. All right, we are not looking at odd numbers, prime factors. All right, let's look at question number 5. There's a sum of, okay, the sum of two numbers is -1, and the product of the same number is, not ID, is -30. What are the numbers? The easiest way to look at this is to find out -30. What numbers give us 30? Ask yourself that. All right? What numbers give us 30? You cannot start at 1 because 1 definitely will give you an answer. Anyway, okay, numbers that give us 30, it's 1 times 30. Then we have 2 times 15. We have 10 times 3. We have 6 times 5. I think they are done. These are the numbers that we can only. Why are we doing this? Because I'm looking for numbers that I will multiply to give me a negative what? 30. And when I add, they give me negative what? 1. Sum, meaning when I add. Product, meaning when I multiply. You understand? So of these numbers, which one can give me a -1? Definitely when I add 1 and 30, this can't. So this one goes. 2 and 15, this one is out. 10 and 3, this is out. But the possible answer could be here. Why? There's a relationship a little bit. But now I need a -1. When I add them, I get a -1. That means it's supposed to be 6, -6 plus 5. -6 plus 5, it will give me a -1. So the values are, or the numbers are, -6 and 5. You can test them on your calculator. Just 6, -6 plus 5. I have a -1, so they qualify. And when I multiply them, I still get a negative number as 30, which is true. So these are the values that I was looking at. All right, there we go. We have here an answer that says the product of two numbers is 12 and the sum is 8. Come here. Now always start with the product because this one will give you the number nicely. Because which two numbers do you add to get 8? And when you multiply them, they give you 12. What numbers are they? First and foremost, ask yourself what numbers give you, when you multiply them, what numbers give you 12? So it's going to be 1 and 12. That's the first set. Then 2 and 6, 3 and 4. Any other number that gives me 12? None. So this one, when I add the 2, because I remember I need to multiply them to give me 12. Yes, when I multiply these ones, all of them, they give me 12. All right. But then when I add them, when I add this gives me 13. That means it's out. When I multiply these two, they give me 12. But when I add them, I get 8. Wow. So these are the values. All right? Because when I add these ones, they give me 7. For me, I'm looking for the number. I will multiply to give me 12. And when I add them, they give me 8. So the values are 6 and 2. Okay. And this brings us to the end of our revision 2.